Good afternoon, everyone. It is 5:47 p.m. Sunday, July 27th. I'm gonna be a little quiet today. I have my girlfriend in the room. She's sleeping right now, so we're gonna do this a little quiet and probably make it maybe short too, depending on how I feel. So we're gonna continue on with heap questions. Basically, just priority queue. Okay, so given an integer array called numbers and an integer k, we want to return the kth largest element in the array. Note that the kth largest element in the sorted order, not the kth distinct element. Can you solve this without doing sorting? Yeah, I mean, this is not just like throw it in a heap and then just heapify. Oh, oh, opposite. Right. Hmm. I'm gonna figure out. I should probably figure out how to build a max heap because this min heap thing is killing me. All right. Okay. There you go. So, just do a quick flip. Right. I mean, that was fairly simple. Oh, wow. Quick select. Did I remember doing quick select a long time ago? I remember I did this in my algorithms class. I don't know if I think I kind of hated this problem. I like the heap more, to be honest. I think doing priority queue with heaps is pretty fun. Okay. Task scheduler. So I'm given an array of CPU tasks, each labeled with a letter from A to Z and a number n. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. Return the minimum number of CPU intervals required to complete all tasks. This is a heap question. I remember doing this for Quant OA and I got so confused and I couldn't solve this a year ago. I did not know this was a heap question. A, B, B, B. I guess this is a minimization of the idling algorithm. So the absolute minimum number of CPU intervals you would need would be the size of the array, but the maximum could be much greater due to having idling. So if you can minimize idling, you can get rid of that problem. Now what I'm curious about is how to properly use the heap to do that. Trying to think, how would I do this? Oh wow, man. So this is a greedy. Okay. Sure. I think this is frequency based, so I think I can do like a dictionary maybe. We'll do an array. An array of arrays, how about that? So I'm gonna just call this array just because I'm freaking lazy, and then I'm gonna go no, yeah, we're gonna do a dictionary for the meantime. We'll just call it dict. Oh my god. Dictionary, I guess, whatever. And then I'm gonna go for task in task. I'm gonna say if task not in dictionary, then dictionary of task is going to equal a 0, else we're gonna say that dictionary of task plus equals 1. Okay. And then now this is very lazy, but whatever. Now I'm gonna say for key in dictionary. I'm gonna say array dot append, or no, we're gonna do heap q dot heap push key. No, sorry, array, and then I'm gonna do dictionary key doing? This doesn't make any sense. So I thought I had something, but I'm not gonna lie, I'm kind of at a loss here. Oh, shoot. Trying to think of how to do the cooldown one. That one's kind of the actual harder part. Okay, this is pretty tacky, but we'll see. Okay, so what I'm going to do is I'm going to say top equals heap q dot heap pop. Hey, me. Wait, no. I'm going to say array, and then I'm going to say, oh, no, I don't need to do that. I just do array. Okay, so this is going to be the top, and then I will say I will then say if top of 0 does not equal 1, or sorry, is, I guess we'll just say it's greater than 0, just safety measures. And then we'll say cooldown dot append cooldown dot append, and I'm gonna say I'm gonna put time plus n, and then I'm gonna do top of 0 minus 1, and then top of 1. There you go. Okay. This is horribly designed, but whatever. This is what happens whenever you code in Python for too long. Your brain gets fried. And then we're going to do time plus equals 1. Okay. So, that will add in the things, but we need to make sure, nope. Why are we running? Stop it. Okay, yeah. So, put that here. Put this here. I'm going to say, can MBE be 0. Okay. I have a feeling this is going to crash. Like a very strong feeling. This is kind of like really poorly designed. Right. It's like a... Oh, okay. So we got something. Why 10? Why 10? You know what, I'm gonna... Mm. Motherfucker. It's because I'm doing a min heap, not a max heap. Great. Mm. No, wait, hold on. Let me, so I don't accidentally look at the solution. He has max heap somewhere here, right? Ah, you know what, mother. Okay. This is so dumb. I hate this so much. Man. Hmm. What the hell's going on? I don't know why they don't just like have like a proper. Do they? Heap Q max heap. I really just only care about the push, really. I'm not gonna lie. Oh, what the hell? No wonder why it's messed up. I'm all over the place on this one. Let's try that. Bet people are watching probably like slapping their head right now, like, brother. Okay, so okay, so we still are not cooking. Honestly, I don't care. We'll do this. Something like that. It's being repeated. And there's negative 1c. Oh, we're pushing 0. We need to not do that. Negative 1. Alright, okay, so interesting. This is so backwards. Okay, so we have negative 3. Why is it still 6? So it's 2. So it should not be ready to go until 3. So qualify that as 1, 2, 3, and then I put 1 plus 2 plus 1, so 4. Okay, so let's look at it. 1. So we use the A. Duh. Checking that wrong. Okay, maybe get rid of the plus 1. Maybe we don't need the plus 1. Okay, I don't know. I don't think this is gonna really work. Okay, but that's a different problem. This might be a me giving up kind of type of problem. Or just kind of check with the solution. I pass. Sure. Why not? That, like, I understood how to solve it. I just, that kind of sucked. Okay. Design Twitter. Is this one of those locked questions? It's not. I'm not gonna do that today. That's probably gonna be a tomorrow problem. Okay, well, it is 6:18 p.m. Thank you guys for watching, and I'll see y'all tomorrow.